Okay, so this is practice test number 5, and this is problem number 6, similar to problem number 5. You see the formula that you're going to be using at the top of the page, and then the formula for the degrees of freedom. And the problem states that a study was conducted on the miles per gallon of 20 SUVs. Now, the 20 is your sample size, so that's going to be your N. And then it states that the sample mean, the X bar, was 26.00 miles per gallon, and the sample, it should be sample there, sample standard deviation S, was 2.5 miles per gallon. Assuming a normal distribution, construct a 95% confidence interval for the population mean mu. The first thing you need to do is to find your t-value from the t-table that was handed out in class. You need to find the degrees of freedom, and the formula is n minus 1. N is 20, so 20 minus 1 is 19. You have 19 degrees of freedom. You're going to look on that table, and you're going to, for a 95% confidence interval, you're going to go to the third column from the right, which has the value 0.025 at the top of the column. You're going to go down that column until you get to the 19 degrees of freedom, which is over in the column on the left. And where the 19 degrees of freedom intersect with this column, you're going to find your t-value, which is 2.0930. You're going to use that t-value in your equation. So you plug in the different values for the equation. 26.00 is your X bar minus your t-value of 2.0930 times, in parentheses, you have the S of 2.5 divided by the square root of 20. And I would multiply 2.0930 times 2.5, and then when you get that product, you're going to divide that by the square root of 20. You want to make sure you know how to use your calculator properly so you can calculate that value. You should come up with 1.1700. When you do the calculation on the right-hand side of the equation, you should get the same value, 1.1700. The difference is that on the right-hand side, you're adding that quantity. On the left-hand side, you're subtracting it. When you do that calculation at the end, you should end up with the 95% confidence interval as it's shown to you here at the bottom of the problem.